Now that we have learned the rules of exponential functions and of logarithmic functions, we practiced solving a few equations in both worlds. Let's talk about application problems, real world situations where we might use these functions to solve a question, like for example, a chemistry question. The question says chemists use a number denoted by pH to describe quantitatively the acidity or basicity of solutions. By definition, pH is the negative log of hydrogen ion concentration, where hydrogen ion concentration is in moles per liter and is designated by the symbol bracket H. Exponent is a plus sign and then another bracket. Okay? Now what you're given is that many solutions have a pH between 1 and 14, so we can make note of that. And we could say, all right, we're given that 1 is less than the pH is less than 14 in most solutions, okay, or many solutions. Then we also know that pH equals the negative, and this is actually log, so it's log base 10 of hydrogen ion concentration, okay? And you're asked to find the corresponding range of the hydrogen ion concentration. So it would seem reasonable to actually isolate hydrogen ion concentration and examine its range in light of the values given for pH. Okay? All right, so in this particular case, we can see that if we go about solving this equation, that if we do this the way we do it in mathematics, which is what we should do, is we would isolate the logarithmic term. So essentially now we have logarithm on one side equals a number on the other side. Log is log base 10. So we would rewrite this equation, 10 to the negative pH power equals the hydrogen ion concentration. Okay, so we've actually taken the logarithmic equation and we've solved for the hydrogen ion concentration. Now let's go back and look at it in terms of the existing values you already know that the pH lies between. Okay, so since your pH lies between 1 and 14, the value for hydrogen ion concentration in that window would extend from 10 to the negative 1 to 10 to the negative 14. Now, in order to correctly write the range in this case, you would need to ascertain which number is larger, which number is smaller. So we note that 10 to the negative 14 is actually the smaller number. And so hydrogen ion concentration is between 10 to the negative 14th power and 10 to the negative 1st power. Okay, so the most accurate choice in the list that you are given is the last one. Okay, so what we did again, just to repeat, is we found the boundaries, or we were given rather the boundaries for pH. We found the formula related to pH for hydrogen ion concentration. Then we looked at the endpoints of pH, substituted those in the formula for hydrogen ion concentration, and got the new boundaries for the hydrogen ion concentration in this problem.